Now we're going to solve equations containing rational expressions. And again, remember the key difference between an expression and an equation being the equal sign, and how we handle the equations is different than how we manage the expressions. So we have to keep those things in mind, that what we're about to do only applies to equations with rational expressions, not rational expressions on their own. We're going to be using the same process that we do with method 2 when we simplified complex fractions, where we're going to multiply everything by the LCD of our rational expressions. This allows us to clear the fractions. From there, we just simplify, combine like terms, apply any distributive property, and then set the equation in standard form so that we can solve. The other big thing to remember is that our rational equations will often have extraneous solutions. Any values for the variable that will cause the equation or the function to be undefined. So we have to consider the domain of the rational expression as well. So we're going to solve each of these. So first we want to identify the least common denominator. Well, if I have a factor of 5, and I have a factor of 2, and since 10 is factors of 5 and 2, which are already included, then my LCD is just going to be 10. And so we're going to multiply both sides of the equation by 10. Since we have multiple terms, we have to apply distributive property. So let's take an in-depth look at what the operation looks like, and then we'll do some shorthand later on that'll save us a little bit of time and space. Remember, when we multiply a whole number or an expression by a rational expression, 10 times 4x over 5, only the numerators get multiplied because the denominator is a 1 on the 10. So it's 10 times 4x and 1 times 5. So each numerator will be multiplied by the LCD. Now within each numerator, we can actually simplify that factor by the denominator. 10 divided by 5 leaves us with 2, and then we can simplify the numerator as 8x. 10 divided by 2 equals 5. We can simplify by multiplying 3 and 5. 10 will reduce with 10 to completely eliminate, leaving us with 3x. Now we just have a rational equation, a polynomial equation that we can write in standard form, and then we can solve for x. Now we want to check to make sure it's not extraneous. Well, since there's no variables in the denominators, then that means the domain is all real numbers, and then that means -3 is valid. Next LCD, we have a factor of x. We have 3x. We've already got the x included, so we just need to add the 3, and we have a denominator of 3. So our LCD is just 3x. So here's the little shorthand. Again, every single fraction, everything's going to be multiplied by 3x, and it's going to get distributed. So the shorthand is, what I like to do is just write in 3x on each of the numerators. 3x, don't forget to group your binomials, and 3x. And then we can look at the simplification. X's eliminate, giving us 9. 3x's eliminate, giving us x plus 21. Don't forget the grouping. The 3's eliminate, leaving us with 5x. Because we're subtracting, we need to distribute the negative. And then we're left with a linear equation that we can solve. So we combine like terms. I have -12, and we add x to the other side to give us 6x. X equals -2. Now we'd want to check our domain to make sure that it's valid. Well, if x was 0, it would cause that denominator to be 0. Same thing here. X is not allowed to be 0, and there's nothing that would cause this to be 0. So our domain is all values of x such that x does not equal 0. And since x doesn't equal 0, it equals -2, we know it's a valid solution. Here we can identify our LCD as 5x, so we'll multiply everything by 5x. Don't forget our grouping on our binomial. X's will eliminate, leaving us with 30. 5x will eliminate, and the 5 will eliminate. We distribute the negative, We combine like terms. We apply our additive property, and we solve for x. Again, we check our denominator. If I put a 7 in, none of those denominators equal 0, so we know that 7 is a valid solution. LCD, well, they have the same denominator, x minus 2, so we can multiply both sides by x minus 2. That eliminates, leaving us x plus 6, and then we can distribute the 2. We want to go ahead and combine like terms. So we subtract 4 from both sides, we subtract x from both sides, we get a value of x equals 2. Now, if we go ahead and plug 2 back into our denominators, we see that it causes both of these to be 0, which would be undefined. Therefore, this is an extraneous solution. And since there's no other solutions left, then that means we are left with no solution. Here we can find our LCD. Our first denominator has a factor of 2x minus 1. Second denominator has a factor of x. Third denominator, we already have the 2x minus 1. So the LCD is the product of those two. So we'll multiply everything by 2x minus 1 and x, 2x minus 1 and x, 2x minus 1 and x. 2x minus 1 cancels on the first, leaving us with 2x squared. X cancels on the second, leaving us with 2x minus 1. 2x minus 1 cancels on the third, leaving us with just x. When we subtract x so that we're in standard form, we have a second degree polynomial, so we can factor. We want a product of negative 2, but a sum of 1. That's going to be the numbers 2 and negative 1. So we can rewrite our polynomial, so we can do factor by grouping. So we have 2x minus 1 and x plus 1. Apply our zero factor property. X equals 1/2 and x equals negative 1. Now we want to check both of these in our denominators. So if we take x and replace it with 1/2, well, 2 times 1/2 is 1 minus 1 equals 0. Well, we can't have that, so we know that 1/2 is an extraneous solution. We'll do the same thing with negative 1. 2 times negative 1 is negative 2, minus 1 is negative 3, so that's fine. Negative 1 doesn't equal 0, so that's fine. So we know that x minus 1 is our solution, and it's our only solution since 1/2 was extraneous. If we can factor, we want to make sure that we do. We have a difference of squares, gives us x plus 3, x minus 3. Since all the denominators are x plus 3 and or x minus 3, we know that our LCD is the product of x plus 3 and x minus 3. So every numerator is going to be multiplied by those two factors. I'm going to write this out the long way, but you can try the shorthand if you would like. Everything will get x plus 3, x minus 3. X minus 3 will eliminate in the first, and we want to distribute 2x squared plus 6x. Both denominators will eliminate, 6 minus 2x. X plus 3 will eliminate, and we want to distribute x squared minus 3x. Let's subtract x squared from both sides and add 3x to both sides. X squared plus 9x plus 6 minus 2x. And then we can combine like terms. You can also combine like terms first before you bring everything to the same side of the equation. We want to factor. A product of 6 and a sum of 7 is 6 and 1. We want to set both of these equal to 0. X equals negative 1 and x equals negative 6. Since neither of those would cause my denominator to equal 0, then we know that they're both valid solutions. Again, let's factor. So here we want a product of -4 and a sum of 3. So that's going to be the numbers 4 and -1. So 2z squared plus 4z minus z minus 2. We get a denominator of 2z minus 1 and z plus 2. This is already factored as 2z, and here we have a GCF of z. So we're left with z plus 2. So for our LCD, our first denominator is 2z minus 1, as well as z plus 2. Our second denominator is 2 and a z. And our third denominator, we already have the z, and we already have the z plus 2. So our LCD is the product of 2z minus 1, z plus 2, as well as 2 and z. So let's write this out. For that. Two z minus 1, z plus 2, and 2z. So everything's multiplied by that LCD. There, there, and there. Let's go ahead and simplify. What's left in our first one is z times 2z, giving us 2z squared, minus, what's left in the second one is 2z minus 1 times z plus 2. Remember, these are the factors of this original polynomial, so we can save ourselves some time applying our distributive property. 2z squared plus 3z minus 2. And then we're left with 6z minus 3. Actually, sorry, we actually have this 2 over here. Let's not forget about that. So that's 6 times 2z minus 1, and we'll distribute that in a second. We'll distribute the negative here, here, and here. We'll distribute the 6. We'll combine like terms. So we have 2z squared minus 2z squared. Those equal 0. We'll go ahead and add 3z. And then we'll add 6. Divide both sides by 15, and z equals 8 over 15. We look at our denominators. Based on our factors, x is not allowed to be 1/2, because that would cause our first denominator to be 0. X is not allowed to be -2. That would cause the second denominator to be 0. And x is not allowed to be 0 either. And so these are the values that x cannot be, since that is not our value of z. Z is allowed to be. Then we know it's a valid solution.